Hello students, myself Sanjeev Pal, Assistant Professor of WE Department of Regent Education Research Foundation Group of Institution. Today I will discuss another important questions of MAKAUT regarding the Gauss law. The question was explain, derive the Gauss's law. So from where we will start to derive the Gauss's law? So initially I will discuss a brief theory regarding the Gauss's law. First thing, Gauss's law is applicable only for the point charge. So here I have considered two charge. This is charge positive, this is charge negative. And from the positive charge, we have shown the arrow is coming out from that charge. This is the direction of flux. Here the opposite action is done. Here the line of force or flux coming towards the charge. If we consider two charge at a line, we will see the charge will come out from the positive charge and it enters the negative charge. So direction of flux line from positive to negative. Now we know the theory of the electric field intensity. As we know what will be the formula, and we also know the formula of D. What is D? D is the flux density. Okay, so here we have to prove the Gauss's law. What is the theory behind it? If we consider a volume, so inside the volume, if we consider the charge, it may be point charge or it may be lot of point charges. So considered as a charge density inside the volume. So whatever, this is a charge body. Now the question is how much flux will come out from that charge body? The answer is total charge. If we consider Q, then the flux will come out from that body also Q. So same amount of charge will come out as a flux. This is the basic theory of Gauss's law, and I clearly tell you statement you will find in your book. It is not so important. I am not saying like that. It is also important, but it you will find in your book. So I have interest that student must clear the actual object, and in my theory I will clear the object 100%. So kindly listen my every words to get a clear concept, crystal clear concept. So my words was, if we consider the charge value is q, the flux will be q. So this will represent here by using the following line. Q enclosed. What is the enclosed? Enclosed mean the, if we consider a volume, we consider the charge is inside the body. Charge is inside the body. So what will be the total charge? Charge will be the Q, and it is inside. So it will be defined by Q enclosed. Okay, so that's why I have written Q enclosed. That will be the charge. Now it can be explained if we consider throughout the volume, the charge density is rho v, and if we consider the total charge inside the volume by using the volume integration, that will be the expression, and it is very much known to you, so I will not explain. This is the total charge using the volume charge density to show the total charge amount. So this will be the expression, and both are the same meaning, so we can write Q enclosed equal to rho v dv, integration of rho v dv. So this we can write. Okay, so this is a expression. Another thing here, if we consider this volume is enclosed by a surface, definitely if we move throughout the body, if we move all part of that body of that particular volume, you will cover the surfaces, you will cover the total surfaces, total area. So if we consider this will as a surface integration, that time you have to remember how much flux density will come out from that surfaces. So that will be defined by D, and that total amount of flux, as we know from the theory of the Gauss's law, that is the total flux will be the total charge. So flux density will give you the total flux line that will come out from the surfaces. It can be expressed from the using the surface integration, that is d dot ds. And mind it will come out throughout the surfaces, it will cover throughout the surfaces, it will cover all point of the surfaces, that you will get a closed surface integration, and it has defined here by using this closed surface integration symbol. And so this is also a flux. So flux equal to the charge, so it is also equal to the inside the total charge, that is the q enclosed. Now using these two equations, if we explain this, you will find a very brief and very simple expressions. Both we can equate, and here you see these are two are equated here. So these are equated over here. So you will get the Gauss's law. And here we will using the integration. So you will this is the integral form. So this is the integral form of Gauss's law. So this is the first part of that question. What will be the expressions or statement, whatever? I am not proving. I am just telling about the expressions, and this is the Gauss's law integral form. So the very simple things, and my each and every word, if we copy, it will become in 2 pages. Okay, so that is not required. Write in very minimum things. You can note. I am just telling to you. First thing, we write from the theory of Gauss's law, note down, from the theory of Gauss's law, we know the total charge inside the particular volume will be equal to the total flux which will come out from that surface, which will come out from the body, will be equal to the total amount of charge. That means if we consider the total charge is Q, then the flux will come out from that body also Q. So this is a actual concept of Gauss's law. Next line, you will just write these expressions, and mention that rho v is the volume charge density. So the total charge inside the volume by using the volume integration, this will be, and that will be equal to the q enclosed. Similar way, here we consider the surface is the surface charge density, not that the volume flux density is d. So total amount of flux will come out by using the surface integration, that will be the d dot ds. Okay, that is also q enclosed. Now you write this is equation number 1, and now you write it is equation number 2, and equate this 1 and 2, you will get this 2 equation, and you mention this is the Gauss's law in integral form. Now I know from the theory of divergence. Okay, from the theory of divergence. So this is the definition. This is the definition. Okay, so here from the theory of divergence, if we forget about it, you see the expression here. Here, if we divide by rho v, sorry dv, and you write in such a form del v, then this expression will be equal to rho v. Here we are not considering this symbol, so from here you can write. Okay, now you remember this portion actually the representation of divergence. So this dotted line will convert it to this particular expression, this part. This is called the divergence. So this is the short form, and you just copy rho v. This will be the differential form of Gauss's law. Understand? Now this is also called Maxwell equation, first equation. Okay, so this is the two equation. This will be the integral form, this will be the differential form. Here d, you know d equal to epsilon e. So in the particular d, you can write epsilon e. So here is a change of this formation of this integral form. In place of d, I have written rho of epsilon e. And if we consider only e and we take this epsilon, it is a homogeneous, so you can take a common and it will take to the right hand side. You will see this equation. This is also another expression. This is also the which form? This is also the differential integral form. So this is a very simple, but which expression is very much important in your examination? This expression rho dot d, rho dot d equal to rho v. Prove this. This also come in your examinations. But here my question was, as for the MAKAUT question, I have combined both question at a time. State and explain the Gauss's law. So in my first lecture, I covered the statement, and I am not explain or prove. In my next lecture, I will prove the explanation. Thank you. Video ভালো লাগলে like, share and obviously comments. Thank you.